Hello, this is Srikanth Saravanan from SSN College of Engineering, and we are doing a project on weather integrated automated irrigation system for agricultural purposes. Here are my teammates. Let them introduce themselves.
Hi, I'm Prasanna Karthikeyan from EC department.
Hi, I'm Vibhucharan from EC department.
Hi, I'm Karthikeyan, CSE Department, third year.
And we are all third years from SSN College of Engineering. Let us get started with our presentation.
So let's get started with the presentation. Our project title is Weather Integrated Automated Irrigation System. So this is an automated irrigation system which is capable of optimizing the irrigation schedule based on weather forecast, and it provides facilities such as remote monitoring and also contains overriding features, and this is being made sure by cloud services, and we interface it with an app so that it's easy for the consumer to use. And this project is mainly targeted for large scale agriculture and owners of plantations and semi-automated agriculture facilities. And let's take a look at the existing solution. And an important point to note about the existing solution is that many of these systems are not IoT based and IoT enabled, and even in these IoT enabled projects, they are not providing any weather forecasting abilities. So we'll take a little bit of attention towards the existing structure. And in these existing structures, they are using sensors and controllers as well as valves to regulate the amount of water that is being delivered to the crops based on the specific needs. And these specific needs are being decided based on the crops requirements, such as their specific uh, water requirements. And the sensors in these systems detect various factors such as soil moisture levels, temperature, humidity, and rainfall. And the data from these sensors are sent to the controller, which processes the information and decides when and how much water should be delivered to these crops. The importance of this project lies in the fact that the global demand for fresh water will surpass the current supply by as much as 40% by the end of this decade. And we need to be cautious about how much water we are consuming in our regular agriculture requirements. And we also need to consider the fact that many countries are completely automating their farming sectors and are applying novel farming methods. And we feel that this project is focused on the aspect that India should be a role model in this venture.
So the used technology includes where the hardware is Raspberry Pi for the microcontroller and soil moisture sensor, relays and actuator and switches. The software includes Python 3 and the services include Firebase data service and weather API service. So this is an overview of a solution where the sensor collects data and it sends to the controller and it sends to the cloud service for analytics. These data are provided to the client using desktop app or mobile app, and in return the Raspberry Pi controls the water pump, and the weather forecasting data have been collected from the weather forecasting site. So we are assuming a paddy field in our solution, and in our system, the Raspberry Pi periodically checks the field parameters. Assuming a paddy field in our solution. In our system, the Raspberry Pi periodically checks the current field parameters, and if irrigation is required, it checks weather forecast data from web and makes decision based on upcoming weather condition whether to switch on the water pump or not. The above all things takes place in automatic mode, and it can be monitored remotely in an app. The automatic mode can be overridden to manual mode through the app, and through the app, the user can view the sensor data and weather data of fuel's geolocation, and we can be able to switch on the water pump remotely. So the benefits of the system includes minimizing the labor requirements for large-scale irrigation, and power and water consumption can be reduced when forecast predicts rainfall because the present automated system is not concerned about the possibility of rain. And for various crop fields, the irrigation requirement and based on the irrigation requirements, this can be customizable, and we can be able to remotely monitor the field's irrigation status and control the devices and get environmental parameters from the field's geolocation.
Then we move to the flow diagram. First, our device starts and it setups its sensors and other actuators. Then it checks for the internet connectivity. Now we go for the case that the system is in offline mode. Then it only relies on the offline moisture data. The sense that data coming from the moisture sensor, which is locally available. Then once the data is read it also checks the switch states, that is the water pump state and the mode state. Since the offline mode comprises two modes, one is automatic mode, another one is manual mode. In automatic mode, the system again and again checks for the moisture data, and then based on the moisture data, it makes decision for actuation for irrigation. Then now we check for the mode of operation in this place. Then it decided whether it's operate on automatic or manual. Since user is provided with a physical switch to switch between these modes. Once the system is in automatic mode, again as I said, it checks the sensor data and based on that makes decision for irrigation and waits for specific interval for next iteration for checking the sensor data. Or if the system is in manual mode, it checks the state of the switches only. It doesn't bother about the sensor data. Based on the switch state, it actuates the water pump, and again it waits for the specific interval to be checked in the field. Now go for the another case that the internet is connected. Then it starts its online mode procedures. Now it gets the sensor data and connects itself to the database. In our case, it will be Firebase. And also, we prepared the system for paddy based fields, but it can be customizable too. Since in paddy, the water moisture level is so important, so we only included moisture sensor there. If we add a cotton field, the temperature and humidity also plays a major role. So we only use moisture sensor for paddy field. Once the database is connected, the switch states from the user side app or web application is fetched, and based on the switch state, it decides whether to go for automatic mode or manual mode. Since user is again provided with a switch to switch between automatic and manual mode in the app itself. If the user is selected automatic mode, the sensor data is fetched for making decisions. Once the sensor data gives the result of dry, that is irrigation is required. Then the controller fetches weather data from weather API. Then it checks for precipitation for upcoming 10 hours. If there is any precipitation, then irrigation is avoided. If there is no precipitation or no source of water, then it starts the irrigation process by actuating the water pump. Or if the mode of operation is in manual mode, it again checks only the switch states of the app, and it again reflects back in the actuation part of the water pump, and it again waits for specific interval for the next iteration. And we also provided another feature for overriding. We provided another switch in the user side app. There is a button called override. That button will override all the controls in the local switches. Only the remote app only able to control the entire system. If the switch is disabled, both local and remote switches will be operable. Next we go for the screenshots. Then these are overall controls we are providing. These are the circuits, and this is the controls we are providing in a web app. And this is the Raspberry Pi, in our case the controller device, and the moisture sensor for sensing the data from the field. But in real time, there will be many array of sensors which will be sensing the field data. But for testing and prototyping purpose, we only use only one sensor. And also in field, there will be a big water pump which will be working in some three-phase current. But we, in order to mimic the same situation in our prototype, we use an LED with a relay. Then we also interface 5 LEDs to indicate the mode of operation. Since the red LED and the green LED will indicate whether the system is working in online mode or offline mode, and this green and red LED denotes whether it's operating in automatic or manual mode, and this yellow LED will indicate whether the system is operating in overridden mode. Then this white light represents the state of the water pump, and these two switches are the states of operation mode and manual and automatic modes. Since this switch is helpful to switch between offline and online mode, and this switch is helpful between switching the motor switch on and off. Then this web app is actually a scalable web app, since we provide user name and password for authentication, so many users can able to use, and their data can be distinguished between among themselves. then it's the overall circuit we are implemented in the controller side. So as I said, these LEDs for indicating the modes of operation, and these switches are for changing the states between manual and automatic mode and water pump states, and this is the relay. And this is the comparator we used to tune the moisture sensor to fix the threshold. But there is another way to fix the threshold. If we use ADC, we can fix the threshold in the code itself. Then this is the overall UI we are providing to the users. These are the buttons which is used to switch between automatic and manual mode, and this is the button which is used to switch and switch off the water pump. And these are the data we are providing to the users, that what data is the controller is using to make decisions. These are the data from the controller, not from the API. But the controller fetches its data from the API, so that we are make sure that on what data that controller makes its decision from here itself. And we also provided the override button here to make the overrides in the remote app. Then we move to the live demo.
Hello all, this is our project called Automated Weather Integrated Irrigation System. So it is actually a basic device controlled by Raspberry Pi, which is going to be placed in any farming field. So the objective of this device is to control the irrigation system by controlling the water pump in the field using the data such as weather and the field soil moisture data and temperature and etc. So to extract the sensor data, we use the soil moisture sensor. So in order to test this device, so we just fixing this device in a state that the field is in a dry state, that is it is requiring a irrigation. So our device consists of 4 modes, that is 2 of them is online mode and 2 of them is offline mode. So in online mode, so we are actually given some LEDs to represent the user that our device in working in which mode, so that this 2 LEDs denotes whether the system is in online or offline, and these 2 LEDs are denoting that the system is working in automatic mode or manual mode. So combination of both, we can have online automatic, online manual, offline automatic, offline manual. So in these 4 modes, we are just divide this into 2, such as offline and online. So in offline mode, the device only checks in the moisture data from the sensor from the field, and if the sensor requires an irrigation, so this device switch on the irrigation system by switching on the water pump. Or if it is in offline mode in manual, so that it can be controlled here. Using the switch, the device can be moved to offline or online, moved to automatic or manual mode. So this switch is used to that, and this while in manual mode, this switch is used to switch and switch off the water pump. So in order to mimic real field conditions, we just replace that water pump with our LED. So whenever this LED is glowing, that glowing shows that in the field the water pump is working, so the irrigation is started. So in online mode, there is 2 modes, automatic and manual, and which can be controlled using the website we created. So this is going to be the remote user interface, and here we are just giving the user a username and a password, so that many users can. So we are providing a user credentials, and let the user update his or her own credentials, so many users can use this device with a personalized manner. So just we are logging into our site. So this is our remote user front end. This is a website. We just use the website to give our device a graphical user interface. So we are providing the user credentials, so that many users can able to use this device with their own credentials, so that this device can be scaled to many numbers. So just I'm going to log into our site. So our site just look like this, and so here are the controls, and here is the override button. So it enables the device to be overridden in the local controls while in online mode. So this button denotes whether the remote device is connected to internet or not. and this temperature denotes that the field temperature, and these are the controls we are providing to control the remote device such as the water pump. So it basically look like this. In automatic mode, the device itself makes decision based on the weather data it is obtained from visual processing weather API. So using that weather data, the Raspberry Pi compares the threshold rainfall and the probability of rainfall, and based on that it decides whether to switch on the water pump or not. So while in manual mode, user is provided with a switch to control the water pump in a remote area, from a remote area. So you can see that in manual mode I am switched off to the water pump, so that this LED we just use it to simulate the water pump condition in the field is off. When I am switching it on, so this LED is now glowing. So see, you can see that. So that in these all LEDs represent in online mode, in manual the device is controlled. So I'm just moving to automatic mode in online. So now the LED is changed. So these LEDs are meant for the user who is controlling the device locally instead of remote. So these remote website and the local LEDs are synchronized, so the both will change simultaneously while in online. So now we are going to enable the override feature of our project. So this override button enables the local override controls by switching off this remote control manual for a while. So I'm just switched on so that none of these buttons work. So because it is locally controlled, so we are going to move to local controls. So as I said, this switch is used to switch between the modes, that is automatic and manual, and this switch is used to control the water pump itself. And so now, since this LED is green and this LED is yellow, represents this device is overridden for local controls, and this represents the device is running in automatic mode, and this green light represents the device is connected to the online. So that I'm just triggering the local control switches so that it's get enabled. So now the switch is enabled. I'm moving to manual mode. Yeah, now the LED is changed to red. So you can see that in the website also it is changed to manual mode. So now I'm going to control the water pump. Since I switched off the water pump, so that is switched off. When I'm moving to online mode, automatic mode, I'm just switching it on. So it moved to automatic mode. Now it fetches the weather data and makes a decision based on that and updates us cloud so that it can be updated to the website also. So now based on the decision, it switched on the water pump. Since there is no rainfall and probability, so also there is no precipitation in the next 10 hours, so it switched on the water pump. Since to test this device, we just kept the sensor in dry mode, so that when it is dry, so that it represents there is no water in the field, so that it asks for weather data to make the decision. So we in order to test this device in this case, that is in a dry case, so we just kept it outside. So based on that, everything is working.